Hi guys, this is going to be your notes for today. This is assignment number 7. And I'm going to go pretty slowly for you so that you can make sure that you understand this, and you can pause the video at any time and rewind or fast forward. So assignment number 7 is going to be your notes, and then assignment number 8, and I'll explain the particular problems, will be your homework. The first part, I'm going to do pretty much, I think I'll do the odds only. We're going to start with number 1, and the directions say identify the domain and range of each function. So I'm going to teach you how to find the domain and range of a radical function without graphing. So this is the first problem. You should all have your assignment 7 out. You can pause the video until everybody gets theirs out. Basically, what you're going to do is look at the transformations. The transformation is based upon the parent function y equals the square root of x. So the 1/2 transforms the function or changes it. This +2 transforms the function, and this +5 transforms the function. Now, you can graph this and look at the north, south, east, and west, or what you can do is look underneath the radical where there's an x, and this is going to be affect your domain, and then the term that is being added is going to affect your range. So in order to do this, your domain affects obviously the east-west. So your domain for this function, you're going to start out with saying x plus 2 is greater than or equal to 0, and then subtract 2. So x is greater than or equal to -2. And that's your domain. Your range is +5, so y is greater than or equal to 5. And that's it. I'll do number 2 for you. Actually, I might just do all of these to show you the patterns. Y is equal to the square root of x minus 4. So underneath the radical is your domain. You can say x minus 4 is greater than or equal to 0. And then you're going to solve for x. Add 4, add 4. So x is greater than or equal to 4. And you can put that as your domain. Your range is that additional term, and you're going to notice that there's nothing there. So the range is equal to, I should not say equal to, is y is greater than or equal to 0, because there's really no term added here. So these are my 2 answers. And up here, I likewise just put a box around them. Okay. So next, number 3. Okay, number 3, it is y equals the cube root of x plus 2. Now, in order to do this, there's a couple of things. You can say, because there are cube roots, the cube root function itself, so square roots are very minimal. So you should know that the graph of a square root function kind of just looks like that. Or maybe even further down, this one might just start at 0 and go like that. A cube root function kind of looks like a sideways S. And it can change in terms of the look of the function based on the transformation. But for a cube root function, what you should know, it's very simple, is that the domain and the range are always all reals, no matter what. So if you have a cube root function, the domain and range are always reals. If you have a square root function, you have to do a little bit of solving. So let's look at number 4. Number 4 is y is equal to the cube root of x plus 2 plus 5. No matter what, since it's a cube root function, your domain and your range are always going to be all reals. That does not go for square root functions. Remember, square root has there's no number and it's a 2 right here. For cube root, it does. All right, let's look at number 5. This is a new problem, and it says evaluate this function. So I'm going to make a line here. And for number 5, I'm not going to do 6, because once I do 5, you'll be good. The function w of n is equal to 2 times the root of 2x minus 7 plus 5. And they want you to find when w is equal, or when you plug in 8 for w. Or I'm sorry, 8. Try this again. When you're going to plug in 8 for n. And I probably should have changed this to an n on your packet. Please change it to an n because they're using n there. So it's going to be 2 times the square root of 2 times 8 minus 7, and then add 5 to that. So when you do this, you're going to say 2 times the square root of 2 times 8, which is 16, minus 7 plus 5. 2 times the square root of 9 plus 5. Now the square root of 9 is 3, so 2 times 3 plus 5, which would be 6 plus 5, and your answer is 11. Okay? And then you can do number 6 on your own. Let's see, the next section is performing the indicated operation. So if you notice that 7 and 8 are both addition, 9 is subtraction, and 10 is multiplication. So I'm going to do 1 addition, 1 subtraction, 1 multiplication. So let me flip my page. And we're going to start with number 7. Number 7, we have a g of x function, which is equal to 2x. Number 8 is h of x, which is equal to x squared plus 4. And they're asking us to add g of x plus h of x. So g of x is 2x, h of x is x squared plus 4. And what you're going to do is you're going to put these together with like terms, but none of these are like terms. This has a power of 2, this is just a regular x, and that's a constant. So I'm just going to reorder these to make them in proper form. Number 8. Oh, I'm not going to do number 8. I'm going to do number 9 because that's just addition. Number 9, subtraction. So g of a is 2a plus 2. H of a equals a cubed minus a squared. And you're going to find g of a minus h of a. All right, so g of a is 2a plus 2 minus, now when you put a minus sign, you have to put parentheses and you're putting h of a in the next function inside of there. What that's going to do is it's going to change the sign of each function. So this was positive a cubed, and it's going to be negative a cubed. This was minus a squared, it's going to be plus a squared. So now I'm going to order my function. So negative a cubed, I have no other cubes. Then I'm going to go a squared. I'm going to go to positive 2a plus 2. And that is that function. Okay, let's do number 10. 10 is, okay, so we have g of x, and that's equal to 5x. And we have h of x, and that's equal to x squared, x cubed, minus 4x plus 3x, 4x squared plus 3x minus 10. And they want us to multiply. So 5x times x to the third minus 4x squared plus 3x minus 10. So this is just a general distributive property problem. And when you multiply, you're going to be adding exponents. So I'm going to get 5x to the fourth minus 20x to the third, because 1 plus 2 is 3, plus 15x squared minus 50x. And notice I have a 4, a 3, a 2, and a 1, and I can't combine any of those terms. All right, so now we are down to composition problems. This is something new. It looks a little different than what you're used to. This is number 11, and the directions say complete the following composition problems, questions. So we're going to start out with what we kind of did up here. G of t is 4t plus 5. F of t is 3t plus 1. And they want you to find, looking at the g function, they want you to plug in the f function when you evaluate it at -3. So what we're going to do first is we're going to work inside out. You're going to actually plug in -3 for the f function. So always work inside out. So because they're giving you a variable here, I'm going to take the f function and I'm going to plug in -3 for t. So I'm going to get 3 times -3 is -9 plus 1 is -8. So then they say take the g function and you're going to substitute or plug in -8 for t. So let's just do this up here. So 4 times -8 plus 5. So I have -32 plus 5, and that would equal -27. So my end answer is -27. All right, let's see. Let's go on to number, should we do number 12? Okay, let's do number 12. So number 12 is f of n equals 2n minus 1, and g of n equals n squared plus 4n. And they want you to find the f function after or when you plug in 3 into the g function. So let's plug in 3 to the g function. So I have 3 squared plus 4 times 3. So 9 plus 12. 9 plus 12, is 21. Okay. And then once you get that, you're going to use that number. So we evaluated the g of 3. So we plugged in g of 3. So this is the g function. We're going to go to the f function and plug in what we just found. So 2 times 21 minus 1. So 2 times 21 is 42. 42 minus 1 is, excuse me, 41. So there you go. Okay. The other problems on that particular section are pretty much the exact same. So you just have to be careful how you're working your way in and then out. So, okay. The last section that I wanted to talk about was if you didn't have a variable, if you didn't have a number to plug in. So we're going to look at the composition function for number 17, okay? So number 17, it works the same way as what we just did, but you're going to notice there's actually no number to plug in, so we're going to be plugging in expressions. And we're looking at the h function, but we're first doing, we got to plug in the g of n function plug into the h function. All right, so we are plugging in g of n. We do not have a number for g of n. We're going to put this whole thing into h for n. So I'm going to watch this. So I'm going to put h of n is 2 times. Now I'm going to make a big parentheses here because n is no longer n. It says plug in g of n, plug in g of n into h for n. So I'm going to plug in 4n plus 2. Now that I just did 2 times n, so 2 times n minus 5. So I'm going to do 2 times 4n and 2 times 2. So I have 8n plus 4 minus 5. So I'm going to have 8n minus 1, and that's your final answer because there's nothing further that we can do. Let's do 18. 18, there's g of x, 2x plus 4, and then we have h of x, and that's x plus 3. And they want us to make a composition function where we actually plug in h of x into g of x. Well, if h of x is x plus 3, you're going to substitute that whole thing into g of x, 4x. So wherever you see an x, I'm going to plug in x plus 3 and add 4. So this goes into x. Okay, so h of x, what this expression is, goes into x for g of x. So I'm going to distribute 2x plus 6 plus 4. So 2x plus 10 is my final answer. And then you can do the solving by yourself. We can just stop there. It's totally fine. So I'm just going to go up through 18. That last section, solving, we can cover another time. So your homework tonight, I originally wrote this in my sub-plans. I wanted you to do 1 through 14 on assignment 8. So you can work on that right now. Feel free to watch this video again. Thank you. Bye-bye.